Okay, this is practice problem 30.2 from homework 9, and it states a potential difference of 0.080 volts is developed across the 10 centimeter long wire as it moves through a magnetic field perpendicular to the plane of the figure. And for part A, they want us to figure out what is the strength of the magnetic field. So just gone ahead and drawn out that figure given to us. Here's our 10 centimeter long wire, positively charged at this end, negatively charged at this end, and then it's being moved into the magnetic field. Magnetic field perpendicular at a speed of 5 meters per second. So I've just listed out those variables given to us. That potential difference is equivalent to our EMF. We have the length, which we've converted to meters, and then the velocity. And so the EMF is equal to the velocity times the length times the magnetic field, because the magnetic force, from what we learned from motional EMF in chapter 30, the magnetic force on a charge carrier in a moving conductor creates an electric field equal to velocity times the magnetic field inside the conductor, and then the motion of the wire through the magnetic field induces a potential difference equal to VLB between the ends of the conductor. So that potential difference is VLB, so we can just set the potential difference as E, and then using this equation we can solve for the magnetic field. So we just rearrange that, plug in our numbers, and then we get our magnetic field equal to 0.16 Teslas. And then for part B, it wants us to determine the direction of the magnetic field, and that's going to be into the page, because if we use the right hand rule, let's see, so we have velocity, how should I do this? Okay, so we have velocity going up, and then our current is going to be going to the right, because current flows opposite to the direction of the electron. So current's flowing that way, velocity's up, so that means that our magnetic field has to be pointing into the page. And yeah, that all ties into what we're learning in chapter 30 with electromagnetic induction, and specifically the motional EMF in this problem.